Now I'm going to move on to the CMake, CPAC, CTest, CDash. And these are open source tools to build, test, and deploy compiled software, I say, although we are applying it to some work we're doing with the VA on their lump-based healthcare system. So the first thing I'm going to talk about CMake and this build tool, why you want to use CMake, what some of the features are, and you can get, there's a book, there's a web page, and there's an active mailing list. How many people here use like C++? Anybody? Okay, you got it. So CMake is a real popular tool. How many people have heard of CMake? There we go. Okay, so why CMake? Well, it's easy and it works well. So it's a build system that's supposed to just work. So this is actually curl, which is an open source library for doing web access from a C program. You can do FTP, HTTP access. And all the files in red are their build system. And you can see there's a make file B32, that's probably Borland, a VCA, Wacom, Visual Studio 6, a DSW file, some Amiga file, NetWare, Wacom, configure, a whole bunch of stuff. My guess is at any one point in time, all of those never worked together. What happened is contributors came along and said, hey, I got it working on Borland. Can you put my make file in your thing? Sure. Guy sticks it in. 2 years later, a guy says, this Borland make file doesn't work, and I tried it. So essentially with CMake, you'd have a CMake list file up here, one down here, and that would be all you need. And the project would essentially be outsourcing the build to the CMake team. So we would be the ones responsible for maintaining CMake on all the platforms that the user wanted. And then we make sure, our testing of CMake, make sure that all this stuff works. And then if your project works with one CMake build, it should work everywhere. Why use it? Well, it's fast. These are just a couple blog hits I found of people saying how they improve their time with CMake over other tools. I won't spend much time on this. Another reason to use it, well, everybody else is using it. Why aren't you? So these are some interesting things. This one's from OLO, which is a code counting website. So it looks at open source stuff and it tries to look and see how many lines of code are getting changed in particular languages. And the Auto Tools Automake is sort of declining, CMake's heading out. This one is Google Search Trends. And you can see starting in 2006, CMake sort of showed up and started growing. And that was when the KDE, how many people are familiar with KDE? Okay, great. So KDE is the desktop system for Linux. And in 2006, they adopted CMake as their build system. And that gave us a big user base, a big boost, and a lot of people said, well, what's this CMake thing? So that, and Second Life actually uses CMake as their build system. Kipper's done a little bit of work with them. So CMake is actually a family of tools. There's CMake for building. For testing, it's got a CTest, and then there's CDash, and then packaging, there's a CPAC. It's an open source license, a liberal license, BSD style license. The history of it came from the Insight Segmentation and Registration Toolkit around 2000. This is a project we have with the National Library of Medicine. Has anybody heard of the visible human data? Is that one person? So the visible human data set, the NIH created this great idea. They took a body that was donated to science, and they CT'd it, PET scanned it, MR'd it, collected all this data. Then they froze it solid, and they sliced it really thin, and they took pictures along all the slices. So now they've got a data set. So if you're a researcher that writes an algorithm that extracts the heart out of a CT scan, how do you know you got it right? You cut them open, right? Well, usually you can't do that. In this case, the patient has been pre-cut open and pictures have been taken. So they create that data set, and then they had the insight to say, you know what we really need is the algorithms to go along with that. And that goes back to this open science that I was talking about earlier. Because if, this is the way it works, right? A researcher in computer science, the professor reads a paper and says, well, this looks really neat, hands it to the grad student and says, go implement this. 2 months later, he comes back and says, all right, I didn't get the same results. Didn't work. Did he implement it bad? Was the data set wrong? So many things could go wrong, reading a paper and implementing software. So the idea of this was to take the current state-of-the-art in segmentation and registration software and codify it in software, which is quickly becoming sort of the new language of science. It's not mathematics, it's all coded in software. So making sure that software works cross-platform. Anyways, when I was giving the pitch for creating a build system, one of the guys from CMU raised his hand and said, "Phil, why are you creating a new build system? It's going to be I2K build system." And before he let me talk, he sort of thought, he goes, "Oh, wait a minute. You're not talking about writing an I2K build system. You're talking about changing the way everybody builds C++. Like, yes, world domination, that's what I meant. But how does CMake change the way we build C++? Well, I saw David Abrahams is one of the lead developers for the Boost project, which aims to give C++ a set of useful libraries. And he had this really cool slide. He says, here's Java, here's all the classes that come with it. It had sort of hundreds of really cool looking sounding classes. And here's Python, and it's got stuff that does networking and all this stuff. And he goes, and here's C#, and it has pages of classes that come built in. And he goes, here's C++, and it has IOScreen. So, and that's somewhat true, and Boost aims to fix that. They try to provide all those really cool classes and then push them into the standard and provide an open source breeding ground for that to happen, which is a really cool idea. CMake aims to give C++ compile time portability. Like, we can't do the compile it once, run it everywhere of Java, but we can write one single file that describes how to compile it and then have it compile everywhere seamlessly. That's what CMake does. So the same build tool, files for all platforms, easy to make large and small libraries. So one of the things we had to do was make this really easy for researchers. It's Inside Toolkit. It's a big, huge thing with lots of classes, complicated build, but a researcher can build that and with a couple lines of CMake say, find package ITK, add my own code, links to ITK. It's very compact, and they're taking advantage of this big, huge, complex system without much effort on their part. This was a really cool one. There was a guy down in Australia that creates these robots. This thing, I guess Will's seen some of this stuff, right? Didn't you get out there? Yeah, the onboard processing software for these robots is all managed with CMake. And it was kind of a cool story because it was an operating system we didn't support at the time, and he came to me and said, can we add support for this? I said, well, yeah, if you're willing to run dashboards for me. If you're willing to nightly test it for me, because you'll contribute to me and it'll be just like those build files in curl that don't work 6 months from now, because I'll break it and I won't know I broke it. I don't have that operating system, so you're going to have to run it for me. And he has, and it's worked out really well. CMake's, it's a cross-platform thing. One of the interesting things is it generates to native build tools so that you can take advantage of the most precious resource on a project, which is the developer, and they all have their tools that they love to use. I still use Emacs and command line editing, even with Microsoft compilers, because I've got CMake and it can create makefiles for me. Other people love Visual Studio and they're really productive in it, and they can use it too, so you can basically have your cake and eat it too. So the C-Touch silo, this is sort of a different way of looking at the same thing I showed you before. This is a sort of an automated testing. So this is a peer review, one of our open source tools that we helped to write. And it's running a testing here in parallel. It's running like 8 different copies at the same time, doing screen grabs. And then it sends this data when it's done, would get sent to a dashboard. Dashboard looks something like this. It's got sites down the side. And you see a lot of this one's a kitware, this one's a kitware, this one's not. It's somewhere in Canada. Different build names. This is a Linux. That's a Mac, another Linux, some Macs. And this came out of, actually, believe it or not, Six Sigma quality process. So a while ago, Jack Welch, when we were at GE, he came up and said, I'm going to be a Six Sigma company. When you have a big company like GE with 100,000 employees, well, the way to make change is say, everybody has to do it. I don't care who you are, you're going to do Six Sigma. And we're at the research center and we're all going, really? We write papers and throw away our software. What's that got to do with Six Sigma? But a few of us that like software and thought that testing this stuff could be a little more controlled said, wow, maybe we can. What can you measure in software? You can't measure bugs because you knew they were there. You just fix them. But you can measure things like how many tests failed and passed. How many tests ran? How many errors were there during the build? How many warnings were there? How many errors or warnings during the configuration step? How many updates were made in the software? You can also run things like coverage tools automatically every night. You can run things like Valgrind and Purify that detect memory errors every night. And a lot of times these tools, they're somewhat difficult to set up and use, and really developers sort of see them as a last resort thing. But with a dashboard like this, they can be always there, and then you can get the bug earlier before it actually has been in the system for 6 months. If anybody wanted to try it, there is a C-Dash posted at Kitware, my C-Dash. You can just go there and create an account and start sending your data up. The final thing is CPAC, which is much like CMake, except it creates packaging tools. So you can create a nice Mac installer or drag and drop installer on the Mac, or nice Windows installers, and it uses the install rules built into the CMake tool. And that sort of wraps up our process and the tools, and I can take questions now. Probably about a minute or two left.
Oh, I have like 2 minutes for questions. Yeah.
Sure.
So that looks like a lot of really interesting stuff. I wanted to ask you about Git specifically,
sure.
and Git, a larger company. So I mean, Git provides a really broad mechanic for doing version control, but it doesn't really. It's sort of thin on policy as far as like how you should be merging your branches and how you should be sharing code with other developers and stuff. And I was wondering if you could talk a little bit about how that sort of evolved in Kitware.
Sure. So
does that make sense?
Yeah, it does. So the question is really, Git doesn't enforce workflows. It's open to a wide variety of workflows, and basically it depends on the project. And we've done several. CMake itself uses what's called as a branchy workflow. We use the next and master. So we have the developers are working on the next branch. They pull off of master when you go to create a new fix or code. You update your master branch. You create a branch that's my favorite fix. You do your work. When you think it's ready, you merge it into next. And the next is the thing that we're testing in our nightly section of the dashboard. And then master is essentially the release getting built. And what this does is a really interesting thing. In the past, when we done software releases, it's freeze the code, you send out an email, nobody touched the repository, and we're going to freeze the code, and 3 or 4 days later, okay, finally, we've got a release, it's branched, and then, Bob, you're going to maintain that branch. Huh? Me? Well, how did I get that job? And he goes off, and he takes patches, and after about 6 months or so, it gets so far away from the other one that Bob can't tell what the heck's going on anymore, and he says, we need a new release because I can't figure out what's going on anymore. With something like Git, the master branch is essentially building up your release every day. So you're sort of distributing that among your developers. But there's many other workflows. And it's really up to the project, and the people get together and examine different workflows. You can use it just like you would CDS too. So. Any other? Yeah.
Is this the same approach as some of the new Linux developers are using in continuous versions rather than new releases?
Yeah, a little bit. Yeah, the next master thing came from Git development itself. Linus has this sort of hierarchy of developer approach. So he's up at the top, and he's got the keys to the kernel, and he trusts like 5 developers below him. And then they trust 5 people below them, and they trust 5 people below them. And it sort of winds its way up, and they push stuff up to him, and he's the one that pushes it into the final repository. This is a little more, but I think he maintains sort of a next master.
Okay, sorry, that's all we have time for. Thank you very much. Thanks, Bill.